Hello everyone. So we have already learned about the basics of direct and inverse proportions. Today in this video we will be looking at few questions so that you will be able to understand the direct proportions and inverse proportion in a better way and apply the formulas and apply the basic knowledge you have in solving the problems. Okay. So in this exercise we have done few questions in the classroom also, so I will be telling you the fifth one. Okay, the fifth question in this video. So the question is, a photograph of a bacteria enlarged 50,000 times attain a length of 5 centimeter as shown in the diagram. What is the actual length of the bacteria? If the photograph is enlarged 20,000 times only, what would be its enlarged length? Okay, so the question is in two parts. First of all, we have to understand that in this question we are talking about two things. First thing is about the enlargement done, okay, and the second thing is the length of the bacteria. So to start this question, we will write here, we will make a table, and here I am writing the enlargement. So this is the enlargement. It has taken so much of the space, right? So I will write it enlargement like this. Okay, this is enlargement, and the other one is the length of bacteria. Length, I will write length. Okay, so these are the two parts. Okay, so the first thing is he's saying that if the enlargement is done 50,000 times, then the length is 5 centimeters. Okay, so if the enlargement is 50,000, the length is 5. Length I will write in centimeters. Okay, so the length is 5 centimeters. Now if what is the actual length of the bacteria? So if we have to find out the actual length, then the enlargement must be 1. Okay, so because there is no enlargement, that is the actual value, so it will be 1. So what will be the length of the bacteria? Okay, so here we can take this enlargement as the quantity x and the length as quantity y. Okay, so this 50,000 will be x1, this will be x2, this 5, this is in y column, so 5 will be y1 and this will be y2. So you can see that we have to find out what is the value of y2 here. Okay, so obviously while reading this question and while understanding this question, you can easily come to know that it is a problem of direct proportion. How? Because the enlargement done is directly proportional to the length. If you increase the enlargement, the length will also increase. If you decrease the enlargement, there is a less enlargement, then the length will be less too. Okay, so the proportion is direct, and when it is a direct proportion, okay, so you will write this is a direct proportion. So, and you know, in direct proportion, x upon y is always constant. You can write x upon y is equals to constant, or you can write x1 upon y1 is equals to x2 upon y2. This is the formula what we are talking about. Okay, so whenever you find a problem of direct proportions, always x1 upon y1 is equals to x2 upon y2. Okay, so in this question, x1 is 50,000. So I'm putting in place of x1 50,000. y1 is 50,000 and y1 is 5. So in place of y1 it is 5. x2 is, you can see 1, and we don't know y2. So it will be 1 upon y2. 1 upon y2. Okay. So now to find out the value of y2, all I am doing is I'm doing the cross multiplication. I will multiply y2 with 50,000 and 5 with 1. Okay, so it will be 50,000 y2 is equals to 5 and 5, and then y2 will be 5 upon 50,000. Okay, so 5 one time. Okay, so the value of y2 is now y2 is equals to 1 upon 10,000. What is the value? Y2 is equals to 1 upon 10,000. Now, in the previous chapter, you have already studied that you can write this as 1 upon 10 to the power 1, 2, 3, 4. So 10 to the power 4. And this can be written as 10 to the power minus 4. When you move it up on the numerator, the sign of power will change. It is 10 to the power 4. So when you will move it up to the numerator, it will become 10 to the power minus 4. So the value of y2 is 10 to the power minus 4. Okay. So that means, that actually means that the actual size of the bacteria is, what is the actual size of the bacteria? That is 10 to the power minus 4. Okay. So that this is the first part of the question. Now in the second part, it has been asked that if the photograph is enlarged 20,000 times. Okay, so you can write it here only. I'm writing it with red, so you may know that this is the next part. So if the enlargement is 20,000, you have to find out the value of this. Now what is this? You may term it as y3. Okay, this is, let's say, y3. So all I have to do is I have to find the value of y3. So I'm taking this one and this one. I'm just ignoring the second part, x2 upon y2 part. Okay, so it is x1. So this is also a direct proportion. So x1 upon y1 is equals to, this is now x3 is equals to x3 upon y3. Okay, so x1 upon y1 is equals to x3 upon y3. Again, you know x1 is 50,000, y1 is 5, x3 you know 20,000, and y3 you don't know. Okay, so now cross multiply it. You will get 50,000 y3 and 20,000 into 5. Okay, so y3 will be 20,000 into 5 upon 50,000. 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 5, that is 2 centimeters. So if the enlargement is done 20,000 times, the value of y3 will be 2 centimeters. Okay, so this is the answer. All you had to do was first you had to identify whether it is a problem of direct proportions or a problem of inverse proportions. Then you had to make the table that is differentiating the two quantities that are concerned together, and then you just have to use the formula for the direct proportions. Okay, now we have already did the sixth question in class. Try to do the rest of the questions. Each and every question here belongs to the direct proportion only. So you will find this similar method to do these questions. Please try to do these. And if there is any problem, we will discuss it tomorrow. Okay, bye bye.